And we look at the military through the lens of, I guess, Call of Duty. They show a side of the military that's not real. Oh, but this already exists. Like,
What do you think other hard tech startups get wrong often?
They make hardware research project. Small teams of 10 or 20 people are making huge impacts. The kind of technology that would require any other company $100 million, 10 years, and 1,000 people to build, you're building in a couple months in a warehouse in El Segundo.
We're here in El Segundo at PicoGrid's HQ with CEO and founder Zane Mountcastle with his, you look like Tony Stark here. Pretty sweet. We just filmed the S3 episode, and now we're just gonna talk deep and ask Zane a bunch of questions. My first question is that in preparing for this, stalking your LinkedIn, there's an odd, very clear commonality between all the stuff you've worked on, sensors, and now you're sitting in front of these products that provide power and comms, a computer to sensors. So tell me about your obsession with sensors and what led you to founding PicoGrid.
Yeah, I mean, in hindsight, it seems pretty linear. At no point did it feel like that. Kind of going out of college and working with the, Army, spending some years kind of in the dirt, working with those folks. They're really the messy early stages of defense technology that most folks in the military never get to see, right? They see when technology's worked, and that's 5 to 10 years after you had those first those first dirty days in the desert, and that's kind of where I spent a long period of time, and just got to know those folks and the challenges that they had and the military.
So you were in the Army or the military at that time?
I was a contractor.
You're a contractor, but you actually flew to
somewhere. So this was in military installations in the U.S.
Got it.
So the site you saw in Arizona, that was one of our customers. We were doing that. We were doing just up in Ventura County at Point Mugu and San Nicolas Island off the coast, deploying different field sensors. And I can actually send some photos after this if you'd like, of what that looks like. And so it was definitely not glorious technology, but just kind of you got to see the challenges that these people face that seem so solvable, right? There's such an obvious application of technology, and of course, coming from the tech world, we look at technology like everything is a software problem, or like it's not, right? There's a lot of unnecessary deployment of technology, but there's certain cases where you see these parallels with the rest of the world, and to go from you're off base where you're using all this amazing technology and you go on base and you're kind of stuck back in the 80s, it's truly shocking for that to happen and for that to be the U.S. military. And this is not even a controversial opinion, right? This is a widely accepted fact, and the difference has gotten so stark between the rest of the world and what happens in the military. And we look at the military, through the lens of, I guess, Call of Duty, or through the lens of Top Gun, right? And these are, they show a side of the military that's not real, right? Like the day-to-day operations are not as advanced as I think we'd like to believe, right? One of the interesting stories is our head of government solutions, Tony Lugo. He retired at the beginning of last year out of the Army. He spent 28 years, retired as a colonel. His son is right now in the Army. He's serving in Syria, and he's using the exact same technology that Tony used 20 years ago when he was a soldier in the Army.
Jeez.
And you hear these stories all the time.
That's nuts.
It's truly nuts. And like, I think a lot of it comes down to just the industry that we operate in, right? And there was that famous case of the Last Supper in the 90s and this consolidation of defense into, a handful of small companies. And these companies they're not evil. I think the common narrative out there is like, oh, all these companies, they're bad companies. They're really not. Like, they have really good engineering. They have really good, they're really good companies. The challenge is, as with any large company, it's very difficult to develop. And like, there's really not much incentive to do so, right? If you're talking about, a handful of companies that control 80% of contracts, why would you develop, right? You don't need to. Why would you need to kind of move fast and kind of push the envelope? And I think we're seeing now is that's gone on for so long, for the last 20, 30 years, where we're kind of stuck at that time, stuck in the 90s, stuck in the 80s. And the difference has gotten so stark that we can now realize that, right? If you can now no longer ignore it. And I think that's where this entirely new wave of defense technology companies are coming up. And, small teams of, 10 or 20 people are making huge impacts. And the kind of technology that would require any other company $100 million, 10 years, and 1,000 people to build, you're building in a couple months in a warehouse in El Segundo. Like that is a huge step change in technology, and I think we're seeing the industry wake up to like the possibilities of that. And that's not to say these primes are evil, right? I think that's where I think a lot of the verbiage goes, and I think it's just not true. And I think there's a place for these really specialized technologies that no one needs the F-35 beyond the military, right?
I would like one.
I would like one too, but
we don't need it.
But like, there's a lot of tech that just applying common sense engineering that existed outside of the military for decades at this point to solve these problems. There's so much low hanging fruit that completely revolutionizes how things work. Just applying cloud technologies to the military. Like in the past couple years, the military started to adopt cloud technologies, and it's the most clunky adoption you've ever seen, as you can probably imagine. But you can think, how do you fight a war on global scale without using the cloud? You how is that possible? Right? And you can tell yourself, oh, it's for security. It's like we can do everything all the time on the internet. This is a math problem, right? Encryption is a math problem. We've solved it. And this thinking that, I'm going to just like hide behind some kind of closed systems and those systems will all just, maybe text someone on some secure radio system. That is security by obscurity. And that is day one of cybersecurity, what you should not do, right? If you cannot send your data to China and for it to still be secure, it's not actually secure. So let's solve that problem, right? If you can do that, then you can run on any network. You can run on anything. And you can now sort of by default have access to the entire cloud, all the compute, all of the connectivity that's now possible out there. And now you can start adopting these new systems, like kind of what we're building, and we're building for that thesis. You could now have the technology to connect sensors and autonomous systems and all these different devices that need to operate as a single force, right? That's the goal of the military, is operate as a single force. But it's really difficult to do when you're talking about operating a million different vertical stovepipe systems that don't talk to each other, that don't work together. And you're just relying on kind of that swivel chair method to talk to system A and system B and system C, and putting some analysts who's just spent 12 hours in a dark room somewhere in really high pressure scenarios to have them catch the pixel change in this part of one image. Like that's just not something humans are good at. But that's something that machines are incredibly good at. So let's use that. Let's use that to the advantage that, to the best of our advantage.
Off to a very good start for a first question. That was amazing. What led you to actually starting Picogrid? What were those kind of initial moments like for you personally?
Yeah, so when I graduated college, ended up working with the Army Corps Naval Expeditionary Warfare Center for a couple years, where the technology we're building kind of got to that point where we're looking to deploy it into real operations, right? How do we pull this into the field? And the tech kind of hit this wall where when I was building it, it's like I just kind of naively assumed that there would be some kind of system I could plug into, right? Some kind of API that maybe I didn't know about then, but like when I got further off in, there is no, like, that doesn't exist, right? There's no secret system that's coming to save us. It's not there. And it kind of reached the stage where the answer was, okay, well, you can go be handheld by one of the primes doing their kind of like prime sub relationship where they own the contract, they own the customer, they basically own you. You're basically a pass-through for that technology, which wasn't very appealing. We can try to go it alone. And going alone means building the entire stack from scratch in a world that's hostile to your existence, which is really difficult. That's what we did. And then we, kind of day one, what we're doing is solving the problems that I knew firsthand as one of those people who was out in the field that really worked shoulder to shoulder with these teams for years, and kind of understood a lot of the unsexy problems that these people face.
Talking about you guys developing the system, you've gone really fast, really effectively, with really quality engineering. What has been one of the hardest engineering problems, technical problems you faced, and how did you engineer your way out of it?
What have we not faced? I mean, I think one of the hardest problems to solve that we set out to solve, and just kind of, by principle of running this company, is like, how do we make it possible to scale these systems to global scale by default, right? If we are successful, we built out an ecosystem with partner integrations. We built out this entire sort of network of different companies and capabilities on hardware, on software, and everything in between. And for us, that's really a question of scale. And it becomes it becomes a very difficult engineering problem that you kind of have to solve from day one, right? If this technology cannot solve that from day one, it's not ready for it, right? It's just simply not. You can't then retrofit things onto something, right? It's just that if we can't solve that problem, it's not worth building the company. And that's what I spent a lot of my time early on doing, and I think we came up with a solution that really works and continues to surprise me. But when we have a new company or new capability, or sort of the customers are asking for something else, the answer is generally yes. Yes, we can do that. Like sometimes it requires a small degree of code change, or we have software that we deploy to these systems, sort of small executables that allow us to do the translation between the payload and then our API. We've done this so many times, it's a matter of an afternoon of work, right? It's a lot less integration than you'd think. And that includes now integration into the whole suite, right? You can stream data back from these systems, you can process it, and you can also send commands back down to them. And that flow, like that loop, is just so commonplace across all these different systems. Just as an example, yesterday we had a company in the office that we're working to build an integration with, and that's connecting FPV drones into the system, where they need to be able to stream back data in real time with incredibly low latency and then send commands back down to these systems. And so, just kind of experiment with these systems. It's surprisingly possible. It was never built for that. Like that was never something I considered early on, and it is completely possible. And now with a software deployment, we're actually going to be deploying that code to Ukraine, and now have that capability deployed within a matter of weeks. And that's like, by building that infrastructure and like really focusing on infrastructure as infrastructure, rather than trying to retrofit it down the road or whatever else. It's just a really powerful thing that's just never been done in this industry, right? It seems obvious, right? We've seen this happen in other industries, right? I think a surprising parallel is looking at fintech 10 years ago, right? It was dominated by really large institutions that didn't want to work together. All those systems didn't operate together. You had companies like Plaid. You had companies that came together that basically broke down those walls, and it's not to say you're taking pie away from the big players. Actually, a lot of them got much bigger, right? But what you did is you enabled this entirely new sort of world, this new industry in this in this space that that's kind of our vision. That's how where we want to get to, by making it possible for new players to deploy their systems in the field, whether it's hardware or software, on a proven system in a system that the end user trusts. And oftentimes, like, that's the hardest barrier in this world. It's not the technology. It's not making it work technically. It's just building trust with the end user. They need to know that they can rely on the system in a really high pressure scenario. And if they can't, they don't want to use it, because it's going to make their life actually harder, not easier. And that's not what you want to do. And so if we can build that infrastructure, but still allow, build that trust, where they're using the system for, visual camera, or like sort of what they call expeditionary ISR, and then at the same time plug in, a drone, and now have the exact same system working the same way they know and they trust, but now with a different capability, where now they have, they plug in a new payload that does a software-defined radio for electronic surveillance. So now they can understand where electronic surveillance is happening in the vicinity, or whatever it is. Like these are different capabilities that are emerging all the time. And the way this industry operates today is, we can do that. It's going to cost you a few $100 million, and it's going to be ready in 5 to 6 years. The war's over, right? At least ideally, it's over by that point. And you're sort of late to the game, and that's just inexcusable. Right? It's just not. You cannot operate at that speed. We've done this before. Like, we can move very fast. There's like look at the history of, I don't know the exact numbers here, but like looking at the history of like building a lot of the aircraft in World War II. These were designed in like months. Designed, tested, and manufacturing started within months. And now we're lucky if it takes 10 years.
It's pretty insane. We've talked a lot about the past and the current state of kind of the military and the military-industrial complex, which in a lot of ways just it's too complex, isn't very fast at all. What technologies or research do you see the next defining the future of the industry in the next 5, 10, 15 years the most, that have you most excited?
Yeah. I think, where a lot of attention is going is what role will autonomous systems, robotics, whether those are aerial or ground or subsea robotics, what role do they play in the future? And I think it's simply too early to tell. Like, we're seeing the first glimmers of what this looks like in Ukraine. We've seen, the past decade with like the U.S. forces in Iraq and Afghanistan, with how the U.S. forces deployed drones, which was really, frankly, not that indifferent from how we deploy regular airplanes, right? And I think drones have a much more broad set of use cases. There's a really interesting book that I harp on all the time that came out last year called The Origins of Victory, which sort of traces this, which is this kind of cat and mouse game that always happens. You started with, diesel-powered submarines, and then they invented nuclear submarines, and then someone invented, like this sort of, back and forth that goes on to for how technology develops, and we sort of seen the first wave of how drones and then counter UAS will happen. But I think, like, the honest truth is that's not a solved problem, right? It's such a new world that I think in hindsight it'll be clear, but it's not clear now. So I think that's really defining where a lot of attention is going these days, and for good reason. It's become such a big part of what's happening in Ukraine. Is you have a small country with a much smaller military fighting off and then staving off, arguably one of the world's strongest militaries, because of their ability to deploy these new technologies in really novel ways and really creative ways, and deploying small systems at large scale is where the world is going. And we can no longer depend on large, exquisite systems like we have in the past, because they're simply vulnerable, right? If a single, handheld FPV drone with some explosive on it can take out a tank, your tank's going to be gone pretty quick. And then what, right? Tanks are like, that's sort of no longer a solution. You can deploy on any large scale without, at the very least, some sort of countermeasures. And those countermeasures don't really exist yet. In some sense, they do, right? Here and there are some solutions, but nothing of the sort that we need to actually counter this problem on a large scale. So what does it look like down the road? Who knows, right? It's simply too early to tell, and I think anyone who tells you they know what it's going to look like is simply lying to you. But it's a big part of what we consider is, like, what are the big things we're working on right now is integrating some of the autonomous systems into the platform, but also counter UAS, right? And then be able to deploy those capabilities on the fly in the field is really important.
When talking about PicoGrid, what's something that you wish people asked you more about?
We just like finished raising a round, so there's a lot of stupid questions, so we had to answer. Probably shouldn't say that. So I'm just trying to think of what are some of the common ones. Actually, I think one of the common ones that we get is like, oh, but this already exists. Like, Like, what do you mean it already exists? It's like, oh, we can deploy these systems in the field. Like, we've been doing it for years. It's like, how do you think we've been doing it? In what ways? Where? How? And I think there's this assumption, and I think a lot of it's driven by people assuming that the military has all the best technology, which it just frankly, unfortunately, doesn't. Like, that's just in the field. And I think you then talk to anyone in the military and they'll laugh at that, right? That they don't have, like, that technology isn't there. Of course, there's some really advanced systems out there. There really are, including systems that are very much non-public. But the challenge is that these systems don't work together, right? And we don't have the way to actually deploy them. And so, like, can we deploy systems out in the field? No, we can't. We simply cannot at any large scale today. And we assume that we can. But, like, that assumption is really dangerous, because assuming that this problem is solved without really any evidence to that, other than, like, I played Call of Duty once, which is insane to me, but, like, that is truly, like, I know I've referenced this a couple of times now, but, like, that is truly, like, where a lot of people get their understanding of the industry. And it's just not like that. I think it's really
cool. People actually seriously, like, think that, like, because I play Call of Duty a bunch, but I don't think that just makes me.
I mean, because it's, like, sort of realistic, like quasi-realistic. People like
how would that manifest? Would they be like, oh yeah, I run a, why are we, like, giving?
So I think the TAC map, for example, right? The TAC map, where you understand, like, the layout of the land, you understand kind of where things are going. You might not know where the enemy is at all times, but, like, they'll fire a bullet and the dot will show up.
Right.
And then it'll disappear. That doesn't exist.
In real life, if you were to do that, so like you'd be like, it's somewhere in the mountain. We think maybe.
Right. Yeah, and except when we look at the mountain, it's foggy and we don't really have a good outline. We've never been in this area before.
It's echoing. It's
echoing. Like it could be actually behind us. We have no idea.
Right.
And
we don't know who shot it. We don't know
and so we're kind of just relying on, our senses to understand these things. And you can imagine when things are moving very fast, when you're in a really high pressure scenario, you can imagine how mistakes are made, and they are all the time. Really tragic mistakes are made. And we have the technology to make that not the case, and we should deploy it.
Relatively new company, very new company, doing very well, real hardware, actually deployed, revenue, like great. Like in my mind, you're a class act example of a new hard tech startup that is like building stuff successfully. What do you think other hard tech startups get wrong often?
They make hardware research project. Hardware is not that expensive. We have really amazing technology today to make it possible to deploy hardware systems for extremely low cost. I think, unfortunately, a lot of people get really wrapped up in building hardware. And it then becomes a question of how can I make everything custom? How can I make everything extremely performant? How can I think the answer should be, how can I cut as many corners as possible to get something in the field? There's this really, I don't know if it's still there, but I remember a couple years ago, I was looking at Flock Safety's website, and they had a photo of like their engineering team. And what they're basically doing is taking a Raspberry Pi 4 and putting it into a box that they designed, and that was it. And this was, as far as I understood, after they raised like a lot of money, and they were very successful. And I think the lesson there was like, look, this company is doing very well. And sure, it might not be the best performance system in the world. It doesn't have to be. It solves the problem you're out there to solve. And don't make everything a research project is what I think, unfortunately, a lot of people do, and they just burn a lot of money. And hardware can be expensive. But it can actually also be it can be a really good anchor for building extremely good margins. The margins we make on these things are insane. Because, the going rate for one of these systems in the field is about $1 million. That's not what we charge. And, at the same time, we're making, last year we did 76% margins, including all of the hardware, including everything. And so it's certainly possible. But
treat it from like, this doesn't need to be overly complex. How do we do the minimum requirements and make it good, but does not need to be.
Exactly. How do we just get something out in the field? Yeah. I mean, the same way we love to espouse building software, it's like, let's just get something out there, right? Let's build something and get it into the hands of the users and then figure out what's going wrong. I think the first version of these systems, I can probably send you a photo of it, was made out of an 80-20 aluminum extrusion frame. It was, all the electronics were in little PVC boxes. It was the hackiest thing you've probably ever seen. But what it did is allowed us to deploy the technology, in a real scenario, in a real environment. And we were continuously deploying new code to that thing, including in production. And, that allowed us to get to where we are today because we were able to actually fundamentally solve the problem and then kind of expand out.
Totally off tangent question, but we talked about Call of Duty too many times now. Rate the Call of Duty games. Best, what's the best? Just look at the top that comes to your mind. We'll go a little quick refresh question here.
I mean, the Call of Duty Modern Warfare 2, the original one, not the re-release,
right,
was the best one of all time.
Agreed. Okay, we can move on. I think I'm fine with this. I really liked MW3. A lot of people I don't think did, but I liked it.
It's basically Call of Duty Modern Warfare 2,
right?
Which is kind of annoying. They just keep re-releasing the same things. All the maps in Modern Warfare 2 are the same maps in Modern Warfare 3 are the same maps in Modern Warfare 2.
Yeah, I think
the original ones, not the re-release had different maps.
Yeah. Sometimes with the re-releases. Yeah. Okay.
But Halo 3 was the best game of all time.
See, I'm more of an Age of Empires Skyrim guy, which is a weird category of things to be. But I'm also in congruence with it. We're aligned, I think. So you had a pretty I would say ideal route to finding the problem that you're working on with PicoGrid. You were in the field working on the thing for many years. I don't think a lot of founders get that. Some do actually, but for hard tech founders specifically, how do you advise, or how would you, if you had to go and do it again or something like that, how would you advise founders to find good problems how might you reapproach that if you didn't have that?
Yeah.
Yeah.
I mean, I think people have there's a lot of problems that are out there that are solvable with the right lens. And there's a lot of problems that we sort of accept, right? The problems that I was facing when I was building this technology for the military early on were the problems were just accepted by everyone. Like, this is just how it is, right? We don't have that tech because, I don't know, maybe it's not maybe it's security reasons. I don't know. Maybe I can't do it. I don't know. Like, nobody really kind of challenged it. And kind of everyone just accepted that was how things are done. And so, I mean, I think the advice I'd have for that is just keep your eyes out, right? Like, there is a lot of problems you're going to face day to day. And we'd look at everything as everything's been solved. That's also how we've always looked at everything for all of time, right? Everything's always been solved. And then someone kind of develops something new or just changes things in a small way or changes things. And, there's a lot of problems out there. And I think I was very lucky to have this experience working, with the military. And I never served. And so I get into scenarios where, I need to rely on other people's experience because I never had that. And I'm very, transparent about when working with these people, you know more than I do. Tell me what you need. Tell me how this can be better. Tell me how this doesn't work. Be very candid with me about how this is working, how this is not, because I genuinely want to make it better. And I try to empathize with these scenarios, but I'd never been in combat. I'd never had that scenario. And so, it's really I am not perfect for solving these problems. But I'm open to learning and open to having that humility to understanding why this is not working. And I had a really unique experience kind of seeing the early stages of defense technology development in a way that most people don't get to see, including in the military, which gave me, the empathy to understand what it means to build early stage defense technology and the challenges that you're going to face along the way to actually get some technology from a research lab somewhere all the way into operations at large scale. There's a lot of steps in the middle, and most companies do not make that. And so understanding that stage was really critical to starting the company in the first place. But as we scale out, especially as we scale into some missions that, are they're problems that I'd never faced. We have to continue to work with these folks. We hired, almost half our team now is ex-military, and they bring in a lot of the experience that I don't have. And it's just really, really important for that.
You said lenses, that you will look at problems through different lenses often. This is a question that I have is can you try to describe how you think your brain works? And what I mean by that is what I mean by that is there's two, I think, ways to specify it a little bit. One is whenever your brain encounters a problem, what are some of your brain's knee-jerk reactions to respond to it? What lenses do you find yourself commonly looking at the world through, whether in work or out of work?
I've since learned this is kind of a common thing among a certain class of people, or a certain type of person. But I just have a running list on my phone of different things that could be solved, different problems I've run into. A lot of them are I'd never have any intention building a company or building a product for that to solve it. But it's just you're gonna know problems most acutely when you're facing them versus trying to sit back and whiteboard what are some problems that are out there, right? I think I want to found a company, what do I do? I think it's the wrong way to look at it. It's I have this problem, I'm going to try to solve that, and assuming I can solve it, then I'm going to build a company around that. That's how I think about it. And so having just a random list of just stupid ideas is you just you can go back and be oh yeah, I faced that problem. It's a really non-obvious problem that I ran into that I'd never considered before. And since then I've kind of forgotten all of them until I go back and look at them. I don't know if that answers the question, but
I would say it does. That leads me to the last question, which is also odd and a bit broad. But what's your current life philosophy?
I mean, I think there's a movement that's kind of developed in the past couple of years where people are resistant to any change. I mean, it's not a new thing. That is a very human condition. But to the extent to which, we should stop having kids, we should stop development, we should kind of pump the brakes on AI and all tech development, because it might be bad. Nobody can kind of put their finger on why, but like it might be. And I kind of think of the hysteria that followed every sort of tech change. There was an era where people were advising against reading in bed because it might make people give people bad ideas,
or books in general. When
reading books in general, looking at the printing press and all the challenges between that, it did disrupt things. But I think we can all agree that those were good disruptions. Like those are actually net good for the world. We saw the same thing with electricity. We saw the same thing with the telegraph, with the automobile, with all of these things that have fundamentally improved humankind.
Or like ATMs.
ATMs, the trains, like all of these things were met with such hysteria. And I think if we can't accept the fact that change is good, that development of technology is fundamentally good on net, by now, like what is the more clear truth that's out there, right? And I think like people always point to ways that technology went bad, and I think in some ways it did, right? Look at like nuclear development. Like nuclear power is such an amazing technology where you essentially develop the technology to have infinite, unlimited, clean energy. That is such an amazing unlock. But at the same time, we also develop, nuclear weapons, which have done a lot of damage and have had the potential still to do a lot of damage to a lot of innocent people. And like that is bad. But I think those fears should not prevent the development of technology, even if it isn't clear where it's going. And I think humans have a really amazing way to develop technology and respond to certain things in ways that we never expect. And it's really easy to predict the first order effects of something. So say AI is going to make fake news or sort of, like deep fakes or whatever it is, like it's going to happen. What we don't see is how people are going to respond to that. How, say, video media will become devalued over in-person interactions. Or, things that we can't even expect.
Like, what if AI fake news becoming more popular just makes people way more questionable of the news than they ever would have been, to the point that like news sources of truth that are better than the news develop?
Exactly.
That's a possibility.
I think it's a certain possibility, and I think that's probably how it will develop.
I think it's more likely than like the latter, that like everyone just starts believing like deep fakes of like
exactly.
whatever.
I think it'll build in skepticism that we've sort of lost in a lot of media, where media, for a long time we sort of trusted the big newspapers, and anything that got into the newspapers was true because all these big organizations said it was true. And then we just kind of kept doing that whenever people could just publish anything on the internet. And then we kind of lost the skepticism that we should have, this natural skepticism about everything. And if AI and deepfakes show up and we sort of build that skepticism, even if we're skeptical of real things, like we will find ways to prove what's true is true and what's not is not. And so, the point is, that technology is good. And we can build things that will make the human condition better in ways we can never expect. And like that is a very, very powerful thing.
Zane, thanks for having me. Thank you and also thank you for building PicoGrid. It's inspiring and awesome how quick you guys have moved, and can't wait to hopefully do a follow-up episode in the future.
Hope so.
Cool.
Thank
awesome,
you.
man. We did it. Boom. Thanks for this, buddy. That was great.
Yeah, man.
I know it was a long time, but